Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Zero Sum by SSHRPE, or Sharp? I'm not sure. I'm not sure if it's supposed to be just certain letters or if it's supposed to actually form a sayable word, but here are the rules. We have normal Sudoku rules apply. Fill the grid such that the digits 1 through 9 appear once in every row, column, and 3 by 3 box. We have negator cells. In each row, column, and box, there is one negator cell to be found. Each negator cell contains a different digit, so there are no repeats amongst negator cell digits. And the value of a negator cell is the negative of its digit. For example, say this was a negator cell here. I guess we'll mark it as 8. An 8 in a negator cell would have a value of negative 8. So this value would actually be negative 8 instead of 8. We have killer cages, where values in cages cannot repeat and sum to the magnitude shown in the top left corner. I don't know why he calls it magnitude, but okay, whatever works. So these three digits, the values of these three cells, must add up to 10. The value of these three cells must add up to 0. So that tells you something here. The value of these 4 cells must add up to 7. So that also tells you something there. The value of these 5 cells add up to 1. That tells you something there. We also have German whispers, where adjacent cells on a green striped line must differ in value by at least a 5. So if we had, say, a negator cell here, then this could be essentially almost any value. Well, not any, but say this was like a 7. That would be a value of negative 7, which is going to have a value of greater than 5 with every other digit possible. So this could be valid if it's 7 and 8, because the difference between negative 7 and 8 is 15. So that would be valid. So that's an example of how German whisper lines along with the negator cells could work. We also have region sum lines, where box borders split blue lines into sections. All of the sections on a line must have the same sum value. So, for example, these three digits these three cells must sum to the same, must have the sum up to the same value as the values of these 4, and they sum up to the same value as the sum of these 3 and the same as that 1. So that's an example of how region sum lines work. And finally, we have Kropke dots, where in cells connected by a white dot, values must be consecutive. In cells connected by a black dot, one value must be exactly double the other. Well, we don't have any black dots. Okay. So, for example, if this had a value of 6, this would have to have a value of 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for the cages, this should be fairly easy. 3 digits adding up to 0. That means there must be a negator cell in one of those cells. The rest of the box and the rest of the column cannot be negator cells. So this cannot be negator, this cannot be negator. Same here. 4 digits adding up to 7. The remaining digits in that... the cage cannot have 4 unique digits with no negator cell adding up to 7, because the minimum of 4 digits would be 10. Same with 5 digits adding up to 1. Therefore, the negator cell cannot be here, or cannot be has to be within the cage. Same with 3 unique digits adding up to 5. You cannot have any without a negator cell, so the rest of the column cannot contain a negator cell. Let's see. Anything that's consecutive can never have a negator cell, right? Because you have to have 2 negator cells to be consecutive with any other one, right? Even -1. -1 is only consecutive with -2 or 0. And therefore, that would not fit with any digit. And you can't have 2 negator cells in the same row or column. So this cannot be a negator cell either. These add up to 0. Okay, let's look at the 5 cage that adds up to 1. That means at maximum you can have 1, 2, 3, 4 adding up to, sorry, at minimum, the smallest number you can have for 4 unique digits is 10. And the biggest number you could have subtracting that would be a 9. So that would be 10 minus 9. So the smallest value you could ever have for 5 cell cage with a negator is 1. So that has to match. So then this must be 1 through 4 with 9. Obviously 1 and 3 can't be here, 1 and 3 can't be here. 9 has to be the negator, so it can't be either of these. This can't be 3, so 3 has to be one of these 2 digits here, which means in row 7, where's the 3? Can't be here because of the 3 in the box, can't be here because we need this as a 3. This has to be 5, 6, 7, 8 as the remaining digit in box 8, which means 6 or 7 is always going to be in this white Kropke continuation. Because it's either 5, 6, 7 continuous or 6, 7, 8. So this can't be 6 or 7. So it's 5, 6, 7, but you cannot have 5 or 8 here. So the sum of these 3 digits must add up to, sum of these 3 cells must add up to 5, 6, 7, or 8. Well, this is 4 digits here that would have to, 4 cells here, which must add up to a single digit. For 4 cells to add up to a single digit, one of them has to be the negator, because the minimum of 1, 2, 3, 4 is 10. So one of these 4 is a negator, which means the rest of the cage cannot be. So this can't be a negator, this can't be a negator. We don't know about this. Here we have 2 digits essentially equaling the other digit, which is the negator. The negator has to be a single digit. Here we have 4 digits adding up to 4 cells adding up to 7. What are the possible combinations? You could have 9 with the other 3 adding up to 16. Let's not go that route. Oh, these are 2. Okay, so these digits must have a difference of at least 5. If you don't have the 9 here, you could only have 2 digits, which would be +1 through +4. There's no way those 2 digits could be 5 or more apart. So this has to contain the negator cell. So this cannot be. This cannot be the negator cell then. And this must be a -9, and that could be with any digit. So -9 is fine here. Then you have 1, 2, 3, or 4. We're not sure which. The negator cell must be one of these 3. These two are actually, these are opposite sets, right? This is this. Oh, that's not true. We could have a negator cell here, which could change things. So that's not helpful either. Oh, let's look at this. Can you ever have five normal unique values? So five positive values all be in a German whisper loop with each other. And I believe the answer is no. Right? Because this would be, so assume these are non-negator cells. If you have, that would be like low. You have to have high digits next to it, which would then have to have low digits next to it. So yeah, one of these two must be a negator cell. So this cannot be the negator cell in the rest of the box and the rest of the column. So one of these is a negator cell. Because again, you can't have these be five away from each other. Or five connected in a circle, right? If this were essentially, if again, you're all positive numbers, this would be five away from this and this. So therefore, five or more away from this and this, which means this has to be at least. So this digit is at least five away from both of these, and these are both positive numbers. So that means this is 1, 2, 7, 8, 9 as possibilities. It can't be 3 because there were 3 in the row. These, however, one of these is going to be a negator cell. We don't know which. Same with this, right? If this digit were low, that means both of these would be, well, first of all, this can't be low. And that can't be low. One of these digits has to be high. So say that's high, low, high, low, high. So these are both always going to be high digits. Because there's no way it can be both low, right? If they were both, if these were, or either of these are low, none of these, all of these are positive. You'll always alternate between low digits and high digits. And the 1 through 4 must be next to a high digit. So one of these at least is high, which makes the other one low, which makes that high, which makes that low. So this cannot be low. This has to be high, which is 6 through 9. This is also 6 through 9. But 6 can never be on the German whisper line unless it's next to a 1, or we have a negator cell. But none of these could be negator cells. So it's 7, 8, 9, 7, 8, 9, which is going to be next to 2, 3, or 4. This is next to 2 or 4. Because 3 cannot be here because of the 3 here. And we can't have a 1 in this box. Therefore, this is always going to be next to 2, 3, or 4, which means we have 8 and 9 here as a possibility. It's always going to be next to 2, 3, or 4. Therefore, one of these is going to be a 7. Therefore, one of these has to be a 2. And the other one's going to be next to, say we had a 4 here. 4 can never be next to 2 unique digits on a German whisper line unless one of those were negator, but this can't be 4. So this must be 3. This must be 2, which makes this 7. This can no longer be 7. That means the rest of the digits in box 7 are 4, 5, and 6. They must add up to a total of 5. So it must be 4 and 6 are positive and 5 is the negative. So 5 is in the negator, so but we don't know which one. 2 cannot be any of these digits. Therefore, 2 must be one of these two. 7 can only be next to 1 or negative 9, so it can't be next to 3. Which means where is the 3 in box 8? It must be here. So this is 3. 2 and 4 both could be here. 3 is consecutive with 2 and 4, so this is a 4. 4 can only be next to 9 and a negator cell. So this is the negator cell here, which means this can't be the negator cell. The rest of the row cannot contain a negator cell, therefore this is a negator cell here. Because there's no other negator cell in row 4. 4 can be next to any digit here. 9 can be next to 1, 2, or 3. 1, 2, or 3 can be next to 1 through 4. Consecutive with 1 through 4. 3, 1, 2, 3 has to be with 6 or 7. Therefore, this can't be 3. This is a negator cell. It could be any digit, literally. We have a negator cell here, which means this can't be a negator cell here. This can't be 4. So we know if this is either 1, 2, or 2, 3 as possibilities for this Kropke dot. Therefore, the rest of column 1 can't be 2, 9, 4, 5, or 6 because of the 4, 5, 6 triplet. So it's 1, 3, 7, 8 as possibilities. Hmm. 1 and 2 in row 7 have to be those 3 digits there. 3 is here, 3 is here, so 3 has to be one of these 3 digits. These 2 digits add up to this one. You have 3 unique digits, which must add up to at least 6. So this cannot be 5, right? Because none of these are negator cell. The negator cell in row 4 has to be here. Therefore, these 3 digits are positive, and they must add up to at least 6. It can't be 6 because we have a 3 here. So this is either 1, 2, 4 or 1, 2, 5 here. Right, because this adds up to 7 or 8, because it can't be 1, 2, 3. Therefore, what is this digit? It must be less than 7 or 8. It cannot be 3, so it could be 1, 4, and then this is 5. 2, 4, and this is 6. So it cannot be 1, 3 adding up to 4. It could be 1, 4 adding up to 5, 2, 4 adding up to 6, or 1, 5 adding up to 6. 2, 5 adding up to 7. It can never be 2, 4, 5 because 4 and 5 would already add up to 9, and that's not allowed. Because these 3 by themselves must add up to this. So 1 has to be one of these. 1 and 2 both have to be here. That means in column 6, the 9 has to be one of these 3 cells. Okay. This cannot be 2, 4, actually. Could be 2, 5 here, though. So if this is 1, 4, and 5, that would make this 2. This can never be 2, 4, because that would eliminate all possibilities for that cell. It could be, okay, so this is 7, 6, 5, or 8, 7, 6. So either way, this cannot be 7 or 8, because if we had 8 here, this 7, that would never be 6, because you can't have 1, 2, and 3 adding up to it. Therefore, in box 8, the 8 has to be one of these 2 cells. That eliminates 8 from being this cell, so this can't be 8. This is 9, which makes that 8. If this is 7, this is 1, 2, 4. You have 6 and 5. So then this would be 5 or 6. Okay. So if this is 7, this is 1, 2, 4. And the 1 would have to be here. So it would be 1. Cannot be 1 and 2. It would be 1 and 4. There would be 2. So this would be 2. You'd have 7, 6, 5. So then this would have to be 5 if that was the case. So if this is a 1, 2, 4, this adds up to 7, 6, 5. Therefore, this can't be 7 adding up to these. So it would have to be 1 and 4 here. It can't be 2 and 4 because if 2 and 4 were here, that would eliminate all possibilities for that cell. Okay. Okay, so this would not be 4. This would be, okay, so this would have, if it's 1, 2, 4, 4 is always here. Okay, that's interesting. Oh, that's interesting. We know these 3 digits add up to 10. These 4 must have a negator in it. What's the biggest negator you could have, right? Okay, so this is 1, 2, 4. If it's 1, 2, 5, that would mean this is 8, 7, 6. So this would be 5. That seems like it still could be many things. So you could have 1 and 5 still. And this is 6. That's 2. 2 and 5 here. And that would be 1. And that would be 7. So 1 out of 4, 5 is here, obviously. In box 6, how does this work? Again, this adds these 4 digits, or 4 cells, add up to 7 or 8. Well, say you had a 9 as the negator there. Oh, no, you can't be 9. Because we already have a 9 as a negator here. We have 9 as a negator here, 5 as a negator here. So the most this could be as a negator is 7. And -7 with 6 other digits. Adding up. You either have, okay. So the value of this would be 7 or 8. So with a -7 there, potentially, you have at minimum a value. The digits would have to be 14 plus another 7 because we don't have the 7 here, plus 10. So it's 31, which would make this 6. That's possible. Of course, the 7 doesn't have to be the negator there, right? But anyways, if you had the value of this was 8 with 7. Okay, so this digit can't be 1 or 2. It could be 4, 5, 6, 7, or 9. That's not helpful. We also have a 7 here. One of these is negated. That's definitely okay. So what are the possibilities for column 3? We have only 2, 3, 4, 5, 7, 5, 6, 8. 4 cannot be any of these cells. This can't be 8. So the rest of column 3 must contain a 4. So this is guaranteed 4. It could be a negative 4 in value. We don't know. The rest of column 2 is 1, 5, 6, 7, 9. No 0. 1, 5, 6, 7, 9. So, yeah, this is 1, 5, 6, 7. No 9. Okay, so 1 and 2 both have to be here, right? Nine cannot be here. Oh, where is the 9 in box 5? 9 can't be any of these because you can't have the negator add up to 9 while these add up to less than 9. 9 has to be one of these, so it can't be here, so this must be a 9 here. That means 9 in box 6 must be one of these 3 digits, and 9 cannot be the negator because we already have a 9 as a negator here. So, what does that mean? Oh, 5 in box 7 is the negator, so this can't be 5 here. Therefore, it cannot be 1 and 4. Therefore, this is 1, 2, and 5 adding up. Obviously, 5 can't be here. 5 is one of these digits. This is 6 or 7. This adds up to 8 here. 1, 2, and 5 adds up to 8. 8 makes this consecutive with 7, which makes that consecutive with 6. This must be 5. This can't be 5 and cannot be the negator. And it needs to be 5 as the negator because if you have 5 and 6 minus 4, that's 7. If you have 4 and 5 minus 6, that's 3. Therefore, the negator in row 7 must be one of these 3 digits here, which means none of these can be negator because none of these are negator anymore. So this could have negator here. Okay, the remaining digits in row 7 are 1, 2, 4, and 6. Okay, so we know it adds up to 8. The rest of box 5 cannot have 1, 2, 5, or 3, 9. So it's 4, 6, 7, 8. 8 cannot be here. 4 cannot be here. So 4 is one of these 2 digits here, and 8 is one of these 2 digits here. Since 4 is one of these 2 digits, this cannot be 4. Therefore, this is a 2, 9, 1, 9 pair, or 2, 9, or 1, 9, shall we say. The rest of column 5 must be 1, 2, 4, and 5. 1, 2, 4, 5, 8. Interesting. So this is an 8 in value here. You have 6 or 7. You have 1, 5, 6, 7. Eight, then in row 9 has to be one of those 2 digits. We have a 6, 7, 6, 7 pair in row 4, which eliminates 6 and 7 in the rest of the row. So this can't be 6 or 7. This is 4. This can't be 6. This can't be 4. 4 has to be one of these 3 digits. And these digits are 1, 2, 3, or 5 as possibilities. 1, 2 could be with 7. 1, 3 could be with 6. 1, 5 could be with 4. This can't be 3 because of the 3 in the column. Okay. Again, these cells must values must sum to 8. Can we have a 9 here? Possibly. So again, 1, 2, 7, 1, 3, 6, 1, 5, 4, or it could be 2 and 5 here. 2, 5, 3. Okay. So this must contain a 5 and an 8 here, right? The 5 cannot be the negator. Say the 8 was a negator. Sorry, say the 8 was not a negator. 5 and 8 already add up to 13. The negator would therefore have to be 1, would be 1, 2, or 4. Oh, this can't be 5 because 5 can't be in the negator. Therefore, 5 has to be one of these 3 digits, right? Because 5 we know is in the negator here. 4 and 6 plus 4 plus 6 adds up to 10 minus 5 is 5. So this can't be 5. Therefore, 5 cannot be here. Cannot be here. Therefore, 5 would have to be one of these 3. So again, if 8 is not the negator here, 1 out of 1, 2, 4 is the negator. But you already have 5 and 8, which adds up to 13. 13 minus 4 at maximum is 9. So that can't be the case. 8 has to be the negator here because 5 cannot be. So that means it's 5. You have a negative 8. So the other 3 digits must add up to 16. Sorry, 15. Right? 7 plus 8 is 15. And this is always a 5. You could have 4, 5, and 6, but you cannot have 3 here. So 4, 5, 6 plus negative, or subtracting out 8. This is 15 minus 8 is 7. I don't know why I did that way. So 4, 5, 6 plus minus, adding up 4, 5, 6 and subtracting 8 gives you 7. 2, 5, does that work? 2, 5, and 9? But 9 can't be here. What about 2, 5, and 7? 2, 5, and 7 adds up to 14 minus 8, which is 6. So that doesn't work. So this must be a 4, 5, 8, and this has to be a 6 here. Since this is 6, that eliminates 6 in the rest of the column. So this becomes a 7, 8 pair here. That eliminates 7, 8 in the rest of box 5. So this must be 6. Therefore, these add up to 6 to get a 0 value. So this must be a 1, 5 pair. That means this can't be 1. This is 2. This 4, 5, 8 triplet eliminates 4 here. So this is 1, which makes this 9, which makes that 2, which makes that 4. This then cannot be the negator, so this must be the negator here. We have 7 and negative 9. Negative 9 is 5 away from 2. This can't be 4 or 6, so this must be 5 and is the negator. So this can't be the negator here. This can't be 5. The rest of column 6 is 2, 7, and 9. And this must be a 1, 3 pair. Okay. That means, okay, so this is 1 or 3. That means if all 3 of these digits were positive, they would have to be 1, 2, and 3, and that would eliminate all possibilities for this cell. So this can't be positive. This must be a negator, which means this can't be a negator, so this can't be 8. This can't be 8 because it's a negator. It can't be 6. Could be 2, 3, or 4. That means these two are not negator cells. Okay, this 6 eliminates 6 here, so this is 7, which means this can't be 7. And this can't be 7. And these 3 can't be 7. So 7 has to be one of these two digits here. Oh, this can't be 1, 2, and 7, because if this is 1, 2, and 7, that eliminates all possibilities for that cell. So this can't be 7. It could be 1, 3, 6, or 1, 5, 4, or 2, 3, 5. Okay, again, these digits must, these values of these cells must sum to 8. We have a negator. It cannot be 9. Can 9 ever be in the set? These 3 digits, at least 2 of them are from 1 through 4. It could be 1, 3, and 6 at minimum. It could be 1, 4, 5. So the minimum value for these values, if you had a 9 as a part of the set, would be 2, 3, 6, or 2, 3, and 9, which is 14. So 9 could be essentially here. Interesting. 3 cannot be here because of the 3 in the row. We know 8 is the negative. Okay, this 6 being here as the negator means this can't be 6. So this is 1, which means this can't be 1. This is 2. 2 is consecutive with 1 or 3. This can't be 1 anymore. 1 has to be one of these 3 digits. 1 cannot be here. Therefore, this is a 5, 6, 9 triplet, which eliminates 5, 6, and 9 from the rest of the box. This can't be 6 because of the 6 in the row. We have a 1, 3, 1, 3 pair in row 3, which eliminates 1 and 3 from the rest of the row. So this can't be 3. This is 2 or 4. This is 4. Say we had no negator on here. That would mean this adds up to 1, 3, 4, 5, which is 13. Can this ever add up to 13? And the answer is no, because these two digits by themselves only add up to 12, 4 and 8. And subtracting out 2, that would be 10. And that's not equal to 13. So this has to be a negator, which means this can't be a negator. So this is 8 in the negator, which means this can't be 8 here and can't be 8 here. So one of these two digits is an 8, which leaves an 8 in row 3 being one of those digits. This can't be 8, so this is either 1, 3, 4, which is 8 minus 8, so that's 0, or it's 1, 3, 5, which is 9 minus 8, which is 1. So these two must equal that one, or must be 1 greater than that one. This can't be 2 then, right? So if this is 2, so then this cannot be 8 here. This has to be 2, sorry, not 2, 4, and it must be equal to 2 and 3. That eliminates 2. Okay, so this couldn't be 2 anyways, so 2 has to be here anyways. This 2, 3 pair eliminates 2 and 3 in the rest of the column. This can't be 3. This is 5. These can't be 3 or 5. This 2, 3 pair eliminates 2 and 3 in the rest of the box. This can't be 3. This is 1. This can't be 1 or 3, so it's 7. This can't be 1, 3, or 7, so that's 8. 6 plus 4 is 10. So these digits must add up to 10. So that's 9. This is 5. That's 6. This is 3. 3 must be here then. And it can't be 2, 5 here, so that's 1, which makes this 6. So this is 1, 3, 6 here. That 6 eliminates 6 here. So this is 8, this is 6, 8 eliminates 8 here, so it's 7 and 8. 1 eliminates 1 here, 5 and 1. That leaves these two digits as 2 and 4, and the remaining digits in row 6 as 5, 7, and 9. Okay, we know these add up to 6. Okay, this can't be 7, and this can't be 9. This 1 eliminates 1 here, so this is 3, which makes this 1. This 4 eliminates 4 here, so it's 5. That fails. We have a problem here. This adds up to 9 minus 8, which is 1. And 2 and 3 and 4 does not add up to 1. Where did I mess up? I must have made a bad assumption somewhere. Let's go back to maybe the 7 cage. Ugh. It's so far back. I think this logic is still correct. This logic is definitely still correct. But for the 7 cage, maybe that's not correct. I don't know. Okay, this cage is definitely correct. You can only have 1, 2, 3, 4, and a negative 9 to add up to 1. This does have to be 2 highs here, because these are all non-negator cells. Again, you need, for 3 digits, they can never add up to 5 if they're all positive, so you need the negator cell there. This must be high and high. And cannot be 6 in either of these cases, because if it were 6, it would have to be next to a 1, and these are specifically non-negator cells. So they couldn't be 1. It would have to be at least 2. So it's 7, 8, 9, 7, 8, 9. You have a unique digit between at least 2 and 3, so this must be 8 or 9. That's a 7, 8, 9 triplet, which does force us to be 4, 5, 6. So that's all correct. I think maybe this or here was the problem. This seems like it's correct. 3 and 4, right? Because 8 could not be here. If you had a 4, it was going to be between 2 unique digits, so it couldn't be 4. It had to be 2 and 3. 3 could not be here because one of these had to be 3. So this couldn't be 3. This was 3. 3 it'd be next to 8 and 9. That would be next to 2, because 4 couldn't be here. Therefore, the 2 had to be next to the 7 out of these 3 digits, because the 3 cannot be next to 7, so this was 7. So that's all kosher. That means this is 4. And since this is 4, 4 cannot be next to 2 positive digits on the German whisper line. It has to be next to 9 and a negative digit. So that's a negative digit, which means none of these could be negative digits. This couldn't be a negative digit because you have 4 digits here adding 4 cells here adding up to a single digit. Therefore, one of them must be negator. So this can't be a negator. This has to be a negator. What am I doing wrong here? Yeah, 2, 5, and 7 can't add up to 8. So we're guaranteed a 5 and an 8 here. 5 cannot be the negator because we need the negator 5 here. Is it 1, 2, and 5 is the question, right? Maybe that's the issue. I think this, if this is the case, this has to be 4, 5, and 8 with 6, right? Because 5 can never be the negator. 5 is therefore positive. 8 has to be the negator because if you have 5 and 8, that's 13 already, and 4 as a negator would mean that's already 9 in value, which is too big. Uh... Uh... hmm. This is always going to be 6 or 7, though. Hmm. Because it cannot be 5, because again, 5 can't be the negator here. Ugh. Did I mess something up here? No, because it does have to be 1 or 3 in that case. So it has to be, okay, so once we get to this stage, it seems like this basically becomes problematic, right? So then this has to be 7, 8. That makes this a 6. This can't be 6. This can't be, so that's 7. This can't be 7 or 6 because of the 7 in the box and the 6 as a negator cell. So this is a 1, which makes that 2. Again, this can't be 1 and 7 then. That eliminates 6 in the box. This can't be 2. This is 1 or 3. This is 1 or 3 then. Because this must be 1 and 5 adding up to 6 to give you 0. That makes this 2. 4, 5, 8 makes this 1. Which makes this 9, 2, and 4. This is 2, 7, 9. The 2 has to be a negator here, which means this is 5. This is all fine. This can't be 2. None of these can be 2. Maybe it was this. Okay. So this adds up to... Again, can you have 1, 3, and... This is at... We know one of these is a negator. So 4 and 8 adds up to 12 at most. Minus 2 would be 10. So if we didn't have a negator here, that would be 1, 3, 4, 5, and 8. Sorry, 1, 3, 4, 5 at minimum, adding up, which would be 13, which is already greater than there. Therefore, one of these two must be the negator. Again, this can't be 1, 2, and 3. So this cannot be, this has to be a negator here, which means this can't be negator. So this is the negator then. Yeah, I think we just keep running into that, right? Can't be 3. 8 can't be here because of the negator. This can't be 2 because if it's just 3 and 4. So this must be... Oh, wait, no, that's correct. I don't know what... 2 plus 3 minus 4 is 1. And then 1, 3, and 5, which is 9, minus 8 is 1. Okay, so that was correct. I don't know why. I miscalculated. Or misadded. So this is all still kosher. Okay. Apologies for that. So then this is for... This must be 2 and 3. This 4 eliminates 4 here. So this is 5, which makes this 4. This is not negator. These are not negator. Yeah, so everything was kosher. I just didn't calculate correctly. This can't be 3 because of the 2, 3 pair in the box. So this is 1, which makes this 3, which makes that 1. Again, these must add up to 6. This is minus 4. So you have 4 plus 6 is 10. So this is 1 and 9. This can't be 1, 3, or 8. So this is 7. This can't be 1, 3, or 7. So this is 8. This can't be 9 or 6, so it's 5. This can't be 5 or 9, so it's 6. Okay, this is 3. That makes this a 5. That makes this 3 having to be there. This can't be 7. This 5 eliminates 5 here, so it's 1. That makes that 6. This can no longer be 3, 5, or 6, so that's 8, which makes that 6. 8 eliminates 8 here, so it's 7 and 8. Okay, all of this is still kosher. So this 1 eliminates 1 here, so it's 5 and 1. This must be a 2, 4 pair here. This can't be 9. The rest of row 7 is 5, 7, and 9. Okay, this can't be 4, 5, or 6 here. This is 7 or 9. So we need a negator here. It cannot, the negator cannot be 4, 6, or 1. The negator here has to be 2. So that means we have negative 2 and 8. So the difference between that is 10. So it must be 1 and 9 here. So this must be, this can't be 1 or 2. This has to be a negative 2 plus 1 and 9 to add up to 8, which is what that value is. So that's 7. This can't be 7 anymore. This can't be negator, and it's 4, which means this can't be 4. That's 6. This is 4. This is not negator. One of these two is. So this adds up to 6. We need to get to a value of 8. So the negator here has to be 2 less than the negator of this one, of the other value. The negator cannot be 5. So the negator here is 2. The negator here is 7. Right? Because it can't be 5 or 9. So this must be 7 and the negator, which makes this, so this is 15. That makes set, because negative 7 and 8, the difference between that is 15. Therefore, this must be 9. This must be 5. This can't be negator. The negator in box 3 is a 3, because this is a 2. Therefore, it must be where the 3 is, which means the 3. The negator cannot be here. It has to be in column 7, so it must be here. So this is the negator. It's a 3, which makes this not 3. This is 2. That's 3. This can't be the negator then, which means this the negator. So none of these are negators. We have negators in every row, column, and box. So this is 2. This is 1. That 2 eliminates 2 here, so it's 4 and 2. Negative 3 has to be next to another digit here, and it can't be 7 here. This can't be 2. It cannot be 7. This is -3, right? So it could be many things. What are the remaining digits in row 1? It has to be 5, 7, or 9. This can't be 7 or 9, so this must be a 5, which means this can't be 5 or 7. This must be 9, which makes this a 7. That eliminates 7 here, so that's 2, which makes this a 9. That means this must be 1 through 4 here. Well, it can't be 1, 2, or 3, so this must be a 4. That makes this 1 or 2. This can't be 1, so this is 2, which makes that 1. The rest of digits are 6, 7, and 8. This can't be 6 or 7, so that's 8. This can't be 6 or 7 or 8, so this is 6, which makes that 7. That makes this a 6, this a 8, and this must be 5. Woo! Apologies for that summing. I don't know why I got into my mind that 2 and 3 was equal to 4. It was just strange. Maybe I was just thinking 5 and just thought it was that way. Anyways, that was pretty fun, except for my miscalculation here. But, it happens. Anyways, I hope you had fun watching this solve, and I'll see you next time on Frank Puzzles. Take care.